Okay, so I'm going to start the tutorial session for the second week, week 2. My name is Ranjan Bora, and I am one of the teaching assistant in this course, Biomechanics of Joints and Orthopedic Implants. And you all know that the instructor for this course is Professor Sanjay Gupta. And already I have taken one lecture in the last week on Friday. And if you have missed that lecture, then you can watch the recording of that lecture. Means it is available on the NPTEL website. Means the web page of this course. You will get the link of that video from there. So last week I have discussed some of the basic concepts related to biomechanics. Like I have discussed about force, moments, then free body diagram, then and solve some numerical problems. So you can go through that video. Means it will those will be useful for you in understanding the course. And if you are appearing in the examination for getting the certificate, then those will be helpful. So in today's tutorial, first I am going to solve the assignment from the previous week, week 1. Then I will teach some concepts related to concepts from week 2. Like I am going to tell about the kinematic chain and mechanism and the degrees of freedom. These concepts are covered in week 2. And finally, I am going to solve some problems from biomechanics. So we'll start now. I think you all have submitted the week 1 assignment. So first I will solve that assignment. So you can type or unmute yourself and say the answer for the quiz, means for the assignment of from week 1. And I'm going to also explain to you like why this option is correct. So the first question was which of the following works as an actuator of the limb? So what is the answer? Which of the following works as an actuator? Yes, muscle plus tendon. So option C is correct. And the second question was which of the following attaches a skeletal muscle to bone? 4 options are given. Yes, A is correct, tendon. You can see this figure. Here it is tendon, means it attaches the muscles with the bone. So option A correct. Next, which of the following is not a function of muscle? Yeah. Blood cell formation is not a function. What are the functions of muscle? Functions of muscles are means to produce motion and to maintain our posture and for the heat production. So option A is correct here. Next question is which of the following region in a femur bone consists of hard cortical bone? So this is a femur bone. And this region is epiphysis. And up to, yeah, option B is correct. Up to this region, it is metaphysis. And from here up to here, it is diaphysis. So epiphysis, it is It consists of fully fully cancellous bone. Full cancellous bone. And metaphysis, it is a mix of cancellous and cortical. And the diaphysis, it is a hard cortical bone. So option B is correct. Next question, which is the weakest part of the musculoskeletal system? Yeah, option B, joints are the weakest part of musculoskeletal system. And next question, how many types of joints exist in our body based on the structural classifications? Yeah, three types of joints exist. What are those? Like based on the structural classification, there is cartilaginous synovial joint, then fibrous joint, and the cartilaginous joint. Three types. And shoulder is an example of, yeah, ball and socket joint. So you can see this is a shoulder joint, and we can represent the shoulder joint using this ball, and the socket is here. So means the degrees of freedom of the shoulder joint is similar to those of a ball and socket joint. That's why it can be represented as a ball and socket joint. And next question, which of the following joints contain fluid-filled cavities? No, option A is not correct. Yes, option C is correct. So synarthrosis means this is unmovable joint, and amphiarthrosis means slightly movable joint, and diarthrosis means fully movable joint. So in fully movable joint, we have this, see this picture. In fully, this is a example of diarthrosis joint, and in this you can see this. The fluid filled cavities are present here in the cavity in the joint, means between the femoral head and this pelvis. And the next is the rotator cuff is a group of, what is this rotator cuff in the shoulder? Yeah, B, muscles. Uh, so here is the rotator cuff, tendons and muscles. This is the rotator cuff. And which of the following is not a synovial joint? Yeah, Richards is not a synovial joint. It is unmovable joint, and it is present in our skull. You can see this in the skull. No, elbow joint is a type of synovial joint. Synovial means fully movable joint. So sutures means the joint which is present in the skull. It connects these two bones of the skull. And which of the following joints allows supination and pronation? Pronation. Yeah, that is a good question. Like, what is the requirement of the joint? Mm, I also don't know the answer. Uh, okay, I'll tell you in the next class, or you can post this question in the NPTEL group. Means in NPTEL you can post your queries also if you have any queries. So you can post this question, then I will then answer there. Okay. Coming to this question, which of the following joints allows supination and pronation? No, not the knee joint. It is related to the elbow joint. Here you can see these two motions are called supination and pronation. Yeah, elbow joint is right. Next is condyloid joint belongs to the class of. Yes, diatrosis. So you can see this is the condyloid joint, and it is present in our fingers here. And what type of joint is the temporomandibular? Yes, it is a synovial joint. You can see this is the temporomandibular joint. Means this there is a cavity and means there is the synovial fluid. And why there is the synovial fluid? Means to resist the bone and bone to bone contact. If there is no fluid, then these bones will come in contact with this bone. Okay, 12th question. Yeah, this is a what is that? What is your doubt? Condyloid joint belongs to the class of diatrosis. See, diatrosis means fully movable joint. We can move our fingers, right? So here there is the diatrosis joint. Yeah, that's why it is a diatrosis joint. Means we can move our fingers like this. Yeah. Do you have any doubt? Yes, diatrosis have fluid. Yes. Popping sound in the knuckles. Yeah. Maybe the fluid content is very small here. That's why we can sometimes, or when it becomes dry, in that situation, I think we can hear the cracks, but not always we can hear that popping sound. Means there are some fluid, but the fluid content may be very less. I don't know about it. Mm, no, I think it is not true. Or maybe it is true. I'm not sure. So temporomandibular joint is a type of synovial joint. And which is the largest synovial joint in the human body? Yeah, knee joint. And at gomphosis joint, bone ends are united by? Yes, collagenous fiber. So you can see the gomphosis joint is present in our teeth. Like this is the root of the teeth, and the inner part means the gum. From here, the gum starts. So you can see this here the gomphosis, and there are some ligaments also. And next question is temporomandibular joint is a type of what joint? Yeah, hinge and gliding. Why it is a hinge and gliding? Like I have not included. Yeah, I will come to question 17. First, I will tell about the question number 16. So how does the temporomandibular joint looks like? This is the skull, and here it is the mandible. Uh, Here it is the mandible. So while we open our mouth, like while during the mouth opening, this mandible comes, means this mandible comes like this, and at this joint, the mandible comes like this when we open our mouth. Means it slightly glides also, and this and it means it rotates about the joint center. That's why it is a type of hinge and gliding. Gliding means it means it comes through this. It comes down a little bit, and translates, and then at the same time rotates also. That's why it is a type of hinge and gliding joint. Okay, now question 17. Which of the following factors influence the joint stability? Yeah. So all of these factors influence the joint stability, like shape of the articular surface, then ligaments and tendon. Yes, all of this is correct. And then the main function of the lumbar spine is? Yeah, to bear the weight of the upper part of the body. Yes. So where does the lumbar spine located? Lumbar spine is located at this part. So this is the upper part of the body. So it bears the all the weight from the upper body. and it is an autoimmune type of disorder, which is an autoimmune type of disorder. Yeah, rheumatoid arthritis is an autoimmune type of disorder. And the next question, each vertebra has how many sets of facet joints? Yes. So in this picture, you can see this is a vertebra and it has one facet joint here. And this is one, and here also there is one. So one and two. So it has two sets of facet joint. Next question, which of the following joints can be found on the skull? So we have already seen this. Which joint it is? It is the synarthrosis, yes. Okay, that's all. Now I'm going to talk about some concepts from the week 2 content, and I'm going to discuss some problems. So this will be helpful for you in solving the week 2 assignment. So first I will talk about the degrees of freedom. What is a degree of freedom? So degrees of freedom is the number of independent variables that define the possible motions of a mechanical element in a space. What does it mean? Like we'll assume that the mechanical element is represented by this ball. So now it is in space. Means space means in the air. Means nothing is constraining its motion. So how, and considering it is a three-dimensional, so considering the three dimensions, how many degrees of freedom does this ball have at this present state? Do anyone know? Degrees of freedom of this ball. Anyone, any guess? You want to guess some answer? Okay, I'm going to tell like this ball can, since there is nothing is restricting its motion, so this ball can move around the x-axis and around the y-axis and around the z-axis. Means it can translate along all the axes. So considering, yeah, 6 degree of freedom is correct. You are right. So considering all the translations, it has three translational degree of freedom, and means it can also rotate like about this x-axis. It can rotate, means it can rotate about the x-axis, then also along the about the y-axis and about the z-axis. So it can rotate about all the three axes. So it has three rotational degree of freedoms. So total it has 6 degrees of freedom. 6 degrees of freedoms. Now if we restrict, means if we restrict its one motion, like if we place this ball on a plane, on a surface, so it can no longer, means this y component y component of its this translation is restricted. So this will be restricted. So now at this position, it will have 5 degrees of freedom. Similarly, if we add one more plane along this surface, so this translation will also be restricted, the x translation. So likewise means the how means if we restrict its motion, the degrees of freedom will be reduced. So initially it has 6 degrees of freedom. If we restrict its one motion, one translation, then it will have 5. If we restrict two translation, then it will have 4 degrees of freedom. So likewise, you can determine the degrees of freedom for a problem. Yeah, if we place the plane on the top, same. No. It will not be 3. See, if we place the plane on the top, then it will means it will be free to move in this along these directions, along the z direction. So if we place the plane and then if we apply some load, means if we place the plane here and if we constrained by applying some load, then it will be fixed. So in that case, it will have 3 degrees of freedom, and also it's yeah, in that case, it will have 3 degrees of freedom. Means all the translation will be blocked. But if we simply put a plane and if we don't apply any load, then it will be free to move along this z-axis. Yeah, it will be 4. Yes. Okay. So now I'll take some examples from some from our some biological joints. Then you have to tell me like what is the degrees of freedom for that joint. Yeah. So take this the elbow joint. How many degrees of freedom does the elbow joint have? So how you have to do this? Like you take one elbow joint and what are the uh, possible movements we can do using our elbow joint? We can do flexion extension, right? And we can do the pronation and supination. Means we can rotate about this axis. No, it is 2. See, one is flexion extension means rotating about this axis. Rotation about this axis, and pronation supination means rotation about this axis. So you can see here. See, this is flexion extension. So rotating about this axis, and the pronation supination means rotation about this axis. So how many rotations? We'll count that. Means these 2 is 1 and these 2 is 1. So how many degrees of freedom? It has 2 degrees of freedom. Is it understood? Have you got it? Okay. And next, hip joint. How many degrees of freedom does a hip joint have? So what are the possible movements we can do using the hip joint? Yeah, 3 is correct. So hip joint is a type of ball and socket joint. So you can see here, like we we can rotate about this axis that gives us the flexion extension. Then we can rotate about this. It gives us the internal and external rotation. And one rotation is this, the abduction adduction. So it has 3 rotations. So we can perform 3 rotations using the hip joint. So it has 3 degrees of freedom. And elbow joint has 2 degrees of freedom. Next, knee joint. How many degrees of freedom does a knee joint have? No, not 1. How many movements we can do using the knee joint? So knee joint is a type of 6 degrees of freedom. Okay, so you can see we can do this flexion extension, then means the dominating movement is flexion extension, like means it is the only visible we can only see with our eyes, the flexion extension. The other means other movements of the knee joint are very less. Yeah, so we need to consider all the movements, means even it is slight also, then also we need to consider, means for calculating the degrees of freedom. So means using the knee joint we can do all these 6 types of movement, but the dominating movement is this flexion extension. So it has 6 degrees of freedom. Okay, so okay, next I will tell about the kinematic chain. What is a kinematic chain? So the kinematic chain is an assembly of rigid bodies connected by joints to provide constrained motion. And what is a mechanism? If we fix one link of the kinematic chain, then it becomes a mechanism. So in the slides from week 2, we have seen there are 2 examples of open chain mechanism and closed chain mechanism. So what are those open chain and closed chain? I will tell next. Like, what is an open chain mechanism? Open chain mechanism is a kinematic chain where one link is connected to a single joint. And here the terminal link in that chain is not restrained and is freely movable. Means we can freely move the terminal link. It is not constrained or its movement is not blocked. So you can see it is an example. A person is doing some exercise using the dumbbells. So here, if we draw this system using the links, so how we will draw it? So means we'll draw this forearm as one link, then triceps as one link, and this whole upper body, means upper trunk, as one link. Then again, so here, what are the terminal links? So we can number the links as 1, 2, 3, 4, 5. So which are the terminal links here? Yes, 1 and 5 are the terminal link. So, and you can see means the person is doing the exercise, so it can moves the terminal links, means it is freely movable. The person can freely move the terminal link. So it is an example of open chain mechanism, because here the terminal links are not fixed. It can freely move the terminal links. Now coming to the closed chain. What is a closed chain mechanism? One second. Does it mean all the degrees of freedom are movable? Yes, the means degrees of freedom for the terminal link only. We are only looking at the degrees of freedom of this link. Not we are not we are not concerned about the degrees of freedom all the other system. For these terminal links, yeah, the means degrees of freedom are movable. Yeah, 2 and 4 will also have slight movement, but means 4 means to tell it if it is a open chain or closed chain, we only see the terminal links, not all the other links. Why is it not terminal link? Because between the 1 and 2 there is one joint, the elbow joint. So and here there is shoulder joint. So each link is connected by one joint. Yeah. So the next is closed chain mechanism, which is in which the kinematic chain with every link connected through joints to two adjacent links. Means here one link is connected to two adjacent links, and here terminal link meets enough resistance to restrain its free motion. So we have seen previously what is an open chain. In the open chain, the terminal link is freely movable, but in the closed chain, the terminal link is not freely movable. Means it is constrained by some external object. So you can see a person is doing push up, then it is an example of closed chain, because you can see here these are the terminal links, and we can draw it like a triangle. So if we draw it, and here terminal links are constrained. The terminal links cannot move freely. So if we mark it 1, 2, 3, 4, 5. So it is an example of closed chain, because you can see these the ends of this 1 and 5 link, they are constrained. The person cannot move the terminal link. So have you got it? Okay. Yeah, 1 and 5 is the terminal link. So here are two examples. Example. So can you tell me which one is open chain and which one is closed chain? No, like see properly what the person is doing exercise and which are the terminal links here. No. Yeah, yeah. So the person is doing some exercise in this for some leg movement, doing exercise means doing some exercise with his legs, and here he's doing the one leg squat. So here we are not see we should not see the hands. The hands are fixed. He's moving his legs here. So now can you tell me which one is open chain and which one is closed chain? Yeah, one is open chain and two is closed, because here also we can draw, means we can draw these two legs as one link. Then, so how you can draw this motion? There will comes this hip joint. So 1, 2, 3, 4, 5. So 1 and 5 are fully, means freely movable. So it is a open chain mechanism. And here, um, here these two links are constrained here. This is constrained here and this is constrained here. 2, 3, 4, 5. With respect to hip joint, like how we are looking at the terminal links only. So here 1 and 5 is the terminal link here. Means in both the case 1 and 5 are terminal link. So if the terminal links are free, feet are moving with respect to hip joint. Yes. Yeah, that is true, but we need to see the terminal links only. Means means to find out the open chain or closed chain, we need to look at the terminal links, not with respect to some joint. Yeah, if the terminal links are free, then it is a free joint, means open chain. If the terminal links are constrained, then it is a closed chain. Okay. Okay. So that were the two concepts I have covered. So you will get problems in your assignment, week 2 assignment related to those two concepts. So now I will solve some numerical problems. Last week I have discussed about means I have discussed similar types of problems, and I have solved it using the force equilibrium methods. So today I am going to show you another two methods. Like I will solve this problem using first using the force equilibrium method, then using another method, which is the force vector method. And again, we can solve this problem using the Lami's theorem. So I will solve this problem using all the three methods. So it will be easy for you, like whichever method you will find easy, then you can apply those methods in solving the problems. So read the problem, like it is saying that uh, position of the head and neck as shown in the figure. The head weighs 50 Newton and its center of gravity is located at point C. Fm is the magnitude of the resultant force exerted by the neck extensor muscles. Here is the Fm, and here is the weight of the head. And the neck extensor muscle force is acting at point A, and there is one joint in our head, which is atlanto-occipital joint. It is located at point B. And for this flex position of the head, it is estimated that the line of action of the neck muscle force makes an angle of theta. Theta is given 30 degree, and the line of action of the joint reaction force makes an angle beta equal to 60 degree. So what tension must the neck extensor muscles exert to support the head? And what is the compressive force applied on the first cervical vertebra at the atlanto-occipital joint? So what are the unknowns here? Unknowns are the Fj and Fm. First, it is asking what tension must the neck extensor muscles exert to support the head. That means it is asking what is Fm. And the second is what is the compressive force applied on the first cervical vertebra at the Atlanto-occipital joint. It is asking about FJ. So we have two unknowns here. So we will need two equations to solve this problem. So now I will solve it. First, I will solve it using the first method, method one, which is force equilibrium method. So to apply the force equilibrium method, first we need to draw all the forces which are acting on the head, means in this position. So what are the forces? You can see from this figure, like one force is W and another force is Fj and one more force is Fm. So I will draw all the forces, and means all, you can see all the forces are passing through this point O. So I will draw here the point O, then W, it is acting vertically downward, and Fj is acting F10 angle beta. Fj is acting beta. And how much beta is given? Beta is 60. And Fm is acting at an angle of theta with the horizontal. Here it is Fm. This angle is given theta. You can see this horizon means angle with the horizontal is given theta. So what will be this angle? This angle will also be theta. Theta is how much? Theta is 30. And weight W is given 50 Newton. Now, what is this force equilibrium method? Like we assume this body means the head is in equilibrium. So it tells that summation of Fx equal to 0 means when the body will be in equilibrium. The body will be in equilibrium only when means there is no resultant force. And the resultant of all the forces should be 0. In that case, we say that the body is in equilibrium. So x means this is the x direction and this is the y direction. So summation of Fx is 0 and summation of Fy is 0. These two are the conditions of equilibrium. Okay, now summation of Fx is 0. From this equation, we'll get like along the x-axis, what are the forces that are acting? The component of Fm along the x-axis is Fm cos theta. Fm cos theta, and component of Fj along the x-axis is Fj Fj cos beta, and it is acting in this direction, and Fm cos theta is acting in this direction. So this direction is positive and this direction is negative. So what we will get, summation of Fx equal to 0. From this equation, we will get Fm cos theta is 30 minus Fj cos beta is 60 equal to 0. So we have got one equation. Then using the second equation, what we will get? Fm. Yeah, I will solve it. Then I can tell you the answer. Right now I don't have, so you can wait for solving me. So what we'll get by solving the means this summation of fy is 0. Using the second equation, we'll get what is its component. Its component will be fj sine beta, and along this direction it will have fm sine theta, and this is positive, this is negative. So using the second equation, we'll get fj sine beta is 60 minus fm sine theta is 30 minus 50 equal to 0. So we have got two equations. Now we can solve using this fj. What is sine 60? Sine 60 is root 3 by 2 minus fm sine 30 is 1 by 2 equal to 50. And from the first equation, what we got? We got fm root 3 by 2 equal to fj by 2. So 2 gets cancelled. Fj equal to fm root 3. So we'll put this here. Fj equal to fm root 3. What we will get? Fm multiplied by 3. Root 3 into root 3 will be 3. And it will be 2 minus fm by 2 equal to 50. From here, 3fm minus fm will be 2fm equal to 100. Yeah, fm is 50, you are right. So fm is 50, and what about fj? Fj is 50 root 3. Yeah. So it is good that you are solving it with me. It is good for you. So we have solved it using one method. Next, I will do it using the another method, which is the using the Lami's theorem. So method 2. To apply the Lami's theorem, first we need to draw all the forces. Means we need to draw the force triangles. Okay, I will draw this picture again. So at the point O, W is acting vertically downward, and Fj at an angle 60. Fm is acting at an angle 30. So what are these angles? This angle is 60. What is the total angle? Total angle will be 90 plus 60. It will be 150. And what is this angle? 90 plus 30, 120. So, and what does the Lami's theorem tells about? Lami's theorem tells that we can write one relation which is we can write the ratio of force divided by the sine of the angle between the other two forces equal to, here is one relation which I'm going to write now, Fj divided by sine. What is the angle between the other two forces? Here the other two forces are W and Fm. So between W and Fm, the angle is 60 degree. So Fj divided by sine 60 degree equal to Fm divided by the angle between the other two forces, Fj and W is 150 degrees. So it will be sine 150 degree equal to, and the remaining force is W. W divided by angle between the other two forces, Fj and Fm is 120. So it is sine 120. Now you can use this relation for solving Fj and Fm. So here, what will be the Fm? Fm will be sine 150 upon sine 120 into W. How much it will be? Fm, okay, it is 150. And W. How much it is coming? Have I done anything wrong here? Okay, okay. See, I have written this angle. This is not 120. How much is this angle? See, this is 30 and this is also 30. No, it is not 120. See, this is 30 and sorry. This is 30 and this is 90, right? This is 90 and this is also 30 and this is 30. So 30 plus 90 plus 30, it will be 150. Is it clear? The angle between the Fj and Fm. Yeah, that's why I have written it. I was not getting the answer. Means Fj W divided by it will be 150. So Fm will be equal to W, and Fj will be equal to sine 60 divided by sine 150. W is given 50 Newton. Sine 60 divided by sine 150. Yeah, it is 50 root 3. But the value is 86.6. Okay, is it clear? Have you understood the problem? Okay. So there is one more method, which is the force vector method, which I will show in the next example. There is one more example in this. This is the question in. So if you have any doubt, you can ask. It's related to what I have discussed today. Do you have any doubt? Or is it clear to you what I have discussed up till now? Okay, yeah, that's good. So the next problem is, you can see here one means this is some ancestral means skeleton of some our ancestors. So it is the problem is saying about the body weight momentum for the Australopithecus hip joint is equal to half the interfemoral head distance DIF. So what is this body weight momentum? You can see this figure. The free body diagram is shown here. And the body weight momentum means the momentum of the force because of our body weight, which is 5W by 6. Means the force is acting at a distance of B from this hip joint, from this location of the hip joint. And it is given as half the interfemoral head distance. What is the interfemoral head distance? It is given here, 132 mm. And the abductor momentum C and angle are shown in the third and fourth columns. Abductor momentum C. And abductor momentum means this P is the abductor muscle force, which is acting at a distance of C from the hip joint location. And angle, abductor angle is given 15 degree. What is this angle? So here this is the force P. Abductor angles means the angle made by the abductor force line of action with the vertical y-axis. This angle is given 15 degree. Now we need to find the hip joint reaction forces in the Australopithecus individual. Here it is given the diagram for the hip force problem. P is the abductor muscle force and C is its momentum with respect to the joint center. P is the momentum of the body weight minus the support leg, 5W/6. We are taking the joint center as O. So can you try to solve it? Yeah, moment balance. You have to first use the moment balance. Means there are two steps in solving this. In the first step, you need to find out this. Yes, that is correct. You need to find out the force P using the moment balance. And in the second step, you can use the force vector method for finding the joint reaction force. Okay, I will solve the problem. So first, you need to apply the moment balance, like moment balance about point O. So this is the point O, and at a distance B is force because of the body weight acting, which is 5W/6, and at a distance C, the force P is acting. Okay, so now, and at the point O, there is one joint reaction force Fj. So we need to find out this Fj. Fj is unknown. And also P is also unknown, but we can find out the P. First, we need to find out the P using the moment equilibrium about point O. C is given 36 and B is given half of DIF. B is equal to half DIF. So I will solve in the next page. I will take this clockwise is positive. So this 5W/6, it is producing moment with respect to in the clockwise direction. So it will be positive. It will be, okay, first I need to write summation of moment about O is 0, since it is in equilibrium. And 5W/6 dot, what is the moment term? Moment term is B. P, and moment because of the force P is in anti-clockwise direction. So it will be negative minus P dot C. And we are taking moment about point O, and Fj is passing through the point O. So there will be no moment because of this force Fj about the point O. So we can take these two moments and equate them to 0. From here, B is given half DIF. DIF is given 132. So 5W by 6 dot 132 by 2 minus P dot, how much is C? C is 36 equal to 0. From here, we can find out what the value of P. Value of P will be 5W 132 divided by 6 dot 2 dot 36. How much it is? Yeah, 55. Yes, 55 W by 36. But we can write it in decimal points. How much it will be? It will be 1.53 W. So we have got P in terms of W. We are assuming that W is known to us. So we have got P, and means 5W by 6 is also already given. So now we are left with only one unknown, which is Fj. So to find out Fj, now I will show you how we can apply the vector algebra. Like, okay, so the force equilibrium method is this is the x direction and this is the y direction. We need to again draw the forces at 1.0. Yes, we know two angles. Yeah, we can either use the force equilibrium or we can either use the Lami's theorem. So here it is 5W by 6, one force, then another force P. P is acting, this angle is 15, and Fj is acting in this direction. But we don't know angle of Fj. Do we know it? Angle of Fj is not given. Means this angle. So what is the equation if we use the Lami's theorem? Fj divided by Fj divided by sine 15 equal to P divided by no, P and Fj angle between them is not 180. See, P angle, the abductor angle is given 15. And the joint reaction force will act along this direction, Fj. So will it act along the same direction in which the P is acting? We don't know. So we can assume some angle here. Let us assume this angle as theta. So we know this is 90 degree. So this will be P divided by sine of 90 plus theta equal to 5W by 6 divided by, and how much is this angle? Sine of this is 65, 65, then this is 90 minus theta. So this will be 65 plus 90 minus theta, which will be 90 plus 90 is 180 plus 65 minus theta. So here, how many unknowns we have? We have Fj is unknown and theta is unknown. Yeah, we can solve it using this Lamis theorem. We have two unknowns, and from this Lamis theorem, we can construct the two equations. I'll add here one more slide. Okay. So if we use this Fj divided by sine 15 equal to P divided by sine 90 plus theta, it is cos theta. There is one formula from trigonometry. Sine 90 plus theta is cos theta. So we can write like this. And what was P? P is 1.53 W. It is 3W sine 15 divided by cos theta. And using the second relation, P by cos theta equal to 5W by 6. Sine 180 plus 65 minus theta. So we can separate sine 1, it will be minus sine 65 minus theta. Okay, from this equation, we need to solve for, we need to find theta. (1.53 into 5W). What you are saying about detail? Okay. So we need to use one formula from trigonometry, which is Sin A minus B formula we need to use. Sin A cos B minus cos 65 into sin theta. So it will be minus 6p cos theta into sin 65 plus 6p sin theta cos equal to 5w cos theta. So what is sin 65? 0.9 minus 5.4 p cos theta plus cos 65 is 0.4 into 6, 2.5 equal to 5w cos theta. So here we have got the equation in terms of cos theta and sin theta. So again, we can use one formula, which we can, we can write this sin theta in terms of cos theta. It will be, I am taking this 5w plus 5.4p cos theta equal to 2.5p. We can write sin theta as square root of 1 minus cos square theta. Now we'll square both the sides. It will be 5w plus 5.4p square cos square theta equal to 0.5 square is 6.25 p square 1 minus cos square theta. So here we'll substitute p, which we have calculated. P is 1.53 w. So if we substitute p here, 1.53 into 5.4 plus 5 square 175. It is coming 175 w square cos square theta equal to 1.53 square into 6.45, 14.6 w square minus 14.6 w square cos square theta. So from here we'll get w square is will be cancelled out. So we'll get 175 plus 14.6, 189.6 cos square theta equal to 14.6. So cos square theta will be 14.6 divided by 0.6, 0.077. So from here, cos theta will be 0.28. So what is theta? 73.8 degree. So we have got theta here. Okay, now we can substitute the theta into this equation. Then we'll get Fj. Fj will be sine 15 will go into this side. So it will be sine square 15 and 1.53 W sine square 15 divided by cos theta. So what is the theta? We have assumed theta in this figure. Theta we have got 73.8. Okay, so these two P and Fj are not acting along the same line. You can see it is 73.8 and it is 65. So that was not the right assumption. So they both are acting in a different direction. (1.53 W sine 15 square sine 15 divided by 0.24. It is 0.37 W. So Fj is 0.37 W. Okay. And where it is acting at an angle theta with the horizontal x-axis. So is it clear? Okay, thank you. So if you have any doubt, you can ask. Yeah, thank you. So this was for the today's class. So same means I will again meet you in the next Friday, which will be 5th September, again at the same time. And you can join the class using the same link which you received today. So means yes, means I will solve again some problems, and I will solve the assignment from week 2. And if you have any doubt from the contents from the weeks, then you can ask me your doubt, or you can mail me using in this mail ID if you face any doubt. So I'll prepare some. I mean, I will solve some. I can solve that problems in the next class or in the coming classes. Thank you. Yeah, we'll see you in the next class. Thank you for joining. Okay, thank you. We can close the class today now.